Today we're going to be talking about rational exponent multiplication, which is extremely similar, if not exactly the same, to multiplication for exponents in general. So when two bases are being multiplied, we always add their exponents even if they are fractions. So we're first going to start with two simplifying examples just to jog our memory. In example 1, 9 to the 1/2 is the same as saying 9 or the square root of 9 to the 1. We know that both of these results in an answer of 3 because we are looking for pairs of 2. The index tells us that we are looking for pairs of 2. 9 is a perfect square, therefore our answer is 3. In example 2, 27 to the 1/3 is the same as saying the cubed root of 27. Or the cubed root of 27 to the first power. In this case, we're looking for groups of 3 because our index is 3. We know that 27 can be broken down into 3 times 3 times 3. This is a perfect group of 3, resulting in an answer of 3. For example 3, it's asking us to simplify. Now this is going to our first statement we read, where we add the exponents when the bases are being multiplied. We have the same base of 7, therefore we can add their exponents. So we could simplify this to say 7 to the 1/2 plus 1/2. I know that when I add fractions, I only add their numerators, and I know that 1 plus 1 is 2. I keep the denominator the same, and my base is 7. I can simplify this one step further to 1, resulting in an answer of 7 to the first power, or just 7. In the second example, or example 4, we have a base that is now negative, but we're going to solve it the exact same way, but we need to remember to keep our base negative. Again, this will result in 7 to the first power, or just -7. So nothing changes when the base is negative. But the base must be negative for both if you're going to add the exponents. In example 5, we have two numbers, two different bases. So at this point, we are not allowed to actually add their exponents. However, I know that 9 can be written as a new number using a base of 3. So I'm going to show you what I mean by that. 9 is the same as saying 3 to the second power. 9 and 3 to the second power are the same because 3 times 3 is 9. Now the one thing I need to bring down is the original exponent, which is 1/2. That 1/2 came from here. So again, we changed 9 to 3 squared because they're the equivalent, and we brought the exponent down. I'm now also going to bring 3 to the 1/3 down. So now we need to simplify these two exponents. Well, we know that an exponent to an exponent, we just multiply. 2 over 1, 2 over 1 again. This now simplifies to 3 to the 1/3, which I brought over from the left, and 3 to the 2 over 2, which can be simplified to 1. Now that we have two exponents with the same, we have two bases that are the same, we can now add their exponents. So we have 3 to the 1/3 plus 1. We can't add these two together yet because they do not have the same denominator. So we need to change 1 so that it has the same denominator. So notice that I put a 1 underneath, meaning I made it a fraction. And now I'm going to multiply by 3 top and bottom so that we can have the same denominator as the first fraction. This now gives us 3 to the 1/3 plus 3 over 3. Again, when we add fractions, only add the numerator. So our final answer will be 3 to the 4/3. We added our numerators. 1 plus 3 is 4. we kept our denominator the same. And that would be our final answer. In example 6, we have radicals now. Before we can simplify, we have to change them into exponents because they have different roots, different indexes. This has an index of 2, this has an index of 4. So my first step is to change them into rational exponents. I'm going to put a 1 here just to remind myself that each 2 is to the first power. This becomes 2 to the 1/2, where the index becomes the denominator, the 1 stays in the numerator, times 2 to the 1/4. I have the same base. I'm allowed to add my exponents, so we have 2 to the 1/2 plus 1/4, but like in example 5, we don't have the same base number, so I need to multiply 2 by 2 to create 4, so that we have the same base. So 2 times 2 is going to give us 2 to the 2nd power over 4 plus 1/4. Now that we have the same exponents, the same denominator, we can add our numerators, giving us 2 to the 3/4 power. Sometimes the instructions will say leave it in exponential form. Sometimes it'll ask you to put it in radical form. If I wanted to put this in radical form, I would give it an index of 4 because that is my denominator. 2 would be my radicand, and 3 would be the exponent of that radicand. So note, these two are the same answer. Same thing, one is in radical form, the other is in exponential form. In example 7, we have one of each, a radical and an exponent. I need them to be the same, either in radical form or both in exponent form. For these purposes, I'm going to put them both in exponential form. So this means I would convert x to the 1/2, where my index of 2 becomes the denominator, the 1 is in the numerator, multiplied by x to the 3/2. Because we have the same base, we can add our exponents. 1/2 plus 3/2 gives me x to the 4/2, which can be further simplified to x to the 2nd power. In our last example, just like example 7, radical, exponent, I'm going to convert to exponential form. We don't have the same base, so we can't add our exponents yet. But just like in example 5, where we changed the 9 into 3 to the 2nd power, we can do the same thing with example 8, so that 4 becomes 2 to the 2nd power. 2 to the 2nd power, 2 squared, is the same as 4. Remember to bring down the original exponent. You will be multiplying those together. When we multiply them, we get 6. So our new equation is 1/2 plus 6. I can't add these because we don't have like denominators, so I'm going to multiply by 2 on the top and the bottom so that I can have the same denominator. This becomes 2 to the 1/2 plus 12 over 2, which simplifies to 2 to the 13 over 2. If we wanted to write this in radical form, the 2 would be our index, the base would be our radicand, and the numerator would be our exponent.